Hello guys, welcome back to my YouTube channel. First of all, I would like to say thanks to all my subscribers. Thank you so much for the support. And if you are new to my channel watching this video, please welcome and thank you for visiting my channel. And if you like my video, please don't forget to like, share and subscribe. Also don't forget to click the notification bell icon to get you updated on my next video. In this video, I'm gonna working on this microwave oven where the symptoms is not heating. I will show it to you guys on how to diagnose it, and of course, like on my previous videos, I will always apply the basic troubleshooting. Okay, let us start. Let me focus on the common scenario on this microwave oven. Only two things. One is no power and two is with power but not heating. Let us start to no power. In this condition, you have to focus only on the main fuse. Main fuse is here. I called it low voltage fuse. So we have to focus on this fuse. And next is on this thermal switch, thermostat. This condition is only for no power, and also the standby power supply, and this is the transformer for the standby power supply. And of course we have a control board, also the buttons. Now if the condition of the unit is with power but not heating, then you have to focus only on the high voltage area, the transformer, this one, high voltage transformer, and the door switch, this one. It has 3 door switch, this one, and the other is located here. So attached on it is wires, also this. Any one of 3 of these getting faulty, the high voltage or the microwave oven will not work. It has power but not heating because there is no supply running on this high voltage transformer, because this transformer is giving supply to the magnetron. This switch also, I called it interlocking switch. And of course you have to check the high voltage capacitor and the high voltage diode, as well as this high voltage fuse. I will show it to you guys on how to check this high voltage capacitor and this high voltage diode, also this high voltage fuse, and of course the heart of the microwave oven, this magnetron. Okay guys, I will start first on how to diagnose if the oven is not powering on. First, if no power, as I mentioned, you have to check this fuse. How to check? I will show it to you. I will just remove this fuse, and I am going to show it to you on how to check. Now the fuse was removed, and I am going to check it. My tester selector setting is ×1, and fuse is good, it's moving. But there is another way how to test this one if you don't have multimeter. I will show it to you. Okay, if you have an amplifier like this one and PL, this one is for a guitar amplifier or any kind of amplifier, and of course this PL to PL. First thing, you have to turn on the unit and turn the volume all the way up, and then insert this to input, and you heard the sound. If you touching this tip, it's making sound, and this one no, because this one is ground. Now I will check the fuse using this. The same thing, it's I have contact on this fuse, and on this tip it's creating sound, meaning this fuse is okay. Okay, so I will give you an example. I grab defective fuse, and this one is a defective fuse. When I'm doing the same, it has no sound. There is no sound on this fuse because this fuse is faulty. The line inside is cut. It's not visible to see, so you cannot identify if this fuse is okay or not. So by doing this, you can test it. This one is faulty, this one is good. Okay, I will install it back because this one is good, fuse is good. The next thing you have to test is this thermostat or thermal switch. My setting of my tester is on ×1 just to test the continuity. And thermostat is okay. Thermostat is okay. So the next thing to be checked, if no power, this standby power supply. It has relay, and of course it has transformer, standby transformer. You must get continuity on this transformer, otherwise it will not power on. Those are the things that you need to check: the standby power supply, thermal switch, and fuse. Now I am going to diagnose this unit where the symptoms is with power but not heating. I will plug in the power cord now, and then I will set my meter to 250 because we're going to measure the 220 volts. First thing first, if not heating, you have to focus on the door switch and the magnetron, high voltage transformer, and also the capacitors and diode. But first we have to check the line going to the door switch. I am going to check the primary transformer, the input, if there is a supply running on it. I will turn on the unit now. Start and check the primary supply, and primary supply is not there. There is no supply. No supply. So stop. If there is no supply, meaning there is a faulty line on this side, the door switch, and we are going to trace that one. But you have to find out first the common line. This is the common line. I already found it, and running to this thermal switch. This thermal switch is good. I already tested it, and main line is here. We're going straight to the high voltage transformer. What I am going to do now is to trace the line. I will turn on the unit again. Let's start here. Fuse. Okay, and we go over here because after fuse, we start here, door switch. Okay, it has 220 volts on this line. Oh, there is no running 220 volts on this side, meaning this door switch is faulty. We have to change it. We replace that door switch. Stop. Now I will remove this door switch. Before removing, you have to unplug the power for safety. Okay, I will remove now the door switch. Removing door switch is easy because it has only 2 clips. Okay, the condition of this switch is looks like good stock, unlike for the other one, which is good. This one gets stuck. This one is okay. How to test this one? It's just like a switch. I will set my meter mode on ×1 just to check the continuity. Okay. This one is normally open. Normally open, no continuity. When I push this one, it has continuity, meaning this one is working fine. How about this one? Check this one, and it's open, no continuity, and this one is not moving. We have to replace it and test again the unit. Replace. Replace. Okay, I already replaced it and I have to install it back. Door switch or interlocking switch was already installed, and we run the test again. I will plug in the power cord and let me check the supply if there is a running to 20 volts on it. My meter is already set to 215 volts. I will start the unit now. Start and check the primary voltage of this high voltage transformer. And yes, we do have 220 volts running on this transformer, meaning this microwave oven should work. I will put some water inside and we are going to test it. Let us start. Wait. Okay. If we do have power on this line, but still the oven is not heating. So next, we have to check the high voltage fuse. This one, high voltage fuse, and of course the capacitor. I will check it, and I will show it to you how to test. It's okay now. You see the smoke. Okay, good. Now I will do some test in this high voltage section, but we have to be very careful when doing this. I will do it just to get you aware that this part is seriously dangerous. This part, high voltage. And if you heard a loud electricity spark, meaning there is a fault on the high voltage part where whether it is the magnetron and the mica insulator. Mica insulator is located inside the cavity of the oven, and also check the cavity where the magnetron is mounted. Maybe there is a debris inside that will cause the spark, especially cockroaches. The mica insulator also is causing the spark. When get damaged, you can figure it out if you can see the spot. It can be removed and test the unit without it, but it requires to change it to avoid damage the magnetron. I will show it to you, the mica insulator, how it looks like. And of course, before that, I will check first this high voltage diode, how to test it, and also the capacitor. I will remove it, this one. This one, the terminal of this one is a filament, and the supply on this line is 3.5 volts AC. Because this wires is coming from the transformer, it's only turns, I think this one is 1 turn, and the other line is the coming from the high voltage transformer combined on this, on one line, like here, this one. Other line is from the high voltage transformer, and the other line is connected to the terminal of this magnetron. This terminal is connected directly to the bulb, the vacuum tube inside the magnetron, and it's giving supply. So we have to check this one. Be careful, because even if low voltage coming on it, but if you test it with the respect to the ground, and one of the terminal of this one, it's giving you the 1000 volts, so just be careful. Actually, the voltage of this output transformer, because it's very high, we will put the positive probe on the ground, and before that, I will check it, the supply of this one. Okay, let's check. Okay, so we do have only this 3 volts on this line. I will turn off the unit now. Next thing, I will check the high voltage line. Now I am going to check the high voltage part, and just be careful on this one. I will set my meter on 1000, and now I will start the unit. Just be careful on this one, because it's really high voltage coming out. So my meter is 1000. Just one like that, so don't do it. I am just doing it just to make you aware that this line is a high voltage. Okay, alright, that's it. It's giving you guys the high voltage with respect to the ground, just because this high voltage transformer, the output secondary is attached to the ground, and the other line is running on this capacitor going to the filament. That's why if you are measuring the voltage ground to this terminal, it gives you high voltage. But if you measure only this line, it only gives you 3.5 volts. So just be careful on this. I will show it to you, the fuse. Please watch my video on how to fix this fuse if faulty. Now I am going to check the high voltage capacitor. I will set my meter on times 100k, but before that, make it sure that it has no electricity charge on this capacitor. So grab your long nose and make it short. Okay, we are safe now. So I will just remove this one, and I am going to check the high voltage capacitor. Okay, it shows that this high voltage capacitor is working good. commonly this capacitor is getting shorted or leak, and if this capacitor getting faulty, the fuse will blown up. So capacitor is good. You can also check by setting the selector switch on my tester. Times 1K. Okay, reverse. Okay, but mine I am using times 100, times 100K. Okay, this one is good. Now I will check the high voltage diode. I will remove it. Remove. Okay. Usually this diode you can test it with the putting supply on it, but me I can do check by using my multimeter. This diode looks like no reading, but it doesn't mean that this one is faulty. Okay, I will check it right now. The cathode of this diode is here, connected to the ground, and the anode is here, connected to the capacitor. Now we are going to forward test, and my meter is moving, meaning this one is okay. If I reverse the test, it should have no moving on my meter, so it means this one is okay. Our high voltage diode is good. Now I am going to test the magnetron. My meter mode is set to times 1, so it should have continuity on this one because we are measuring the filament. So this one is good. And test the grounding. It should have no ground on this line, ground to terminal, no reading. If you get reading on this one, meaning the magnetron is faulty, and commonly the getting faulty part is this one, this white one. This is the insulator of the terminal. Actually this one is repairable. You can buy it in an electronic store. It's available to purchase it, and you can replace it. This one is good, no continuity. Yes. Alright, so we are going to check also the high voltage fuse. Okay, high voltage fuse is okay. So working good. If the fuse is always getting faulty, you have to double check this part, the high voltage part, and of course check the condition of the magnetron. Opening of this magnetron is only 3 screws, here, and here. And check the condition of the magnetron. Like for example this one is really faulty. It's visible. So this one is causes loud spark, electricity spark. On this condition, you should replace this magnetron. But if the faulty only is this terminal, you can actually replace it. This is what I am talking about, the mica insulator. So if there is a dark spot on this side or on the other side, you have to replace it because it will cause the electricity spark. Also you have to remove this one. Removing this one is very easy. To check the cavity on where the magnetron is mounted. removing this one is easy only. I will show it to you. This one. Just do it gently. Okay. So this one looks good, and the cavity of the oven, the magnetron output is here. This one cavity is okay, so we do not have problem on this one. I will install it back. Actually, this one is replaceable. You can purchase it on the electronics store. Okay. Thank you so much, guys, for watching. I hope you enjoy my video, and if you like my video, don't forget to like, share, and subscribe to my YouTube channel. And if you have some requests, just put your comment down below, and we'll see you on my next video. Thank you so much, and bye bye.